So I'm going to be talking to you a bit about Dataprep, what it is and how we at Collida have utilized it to build a visualization platform. And I'll start off with a bit about myself. My name is Terry Buchan. I've been in the architectural visualization space for about 10 years. And normally if someone outside of it all will say to me, what's your job? What do you do as a living? I normally just say, well, I like to color things in. And that's pretty much what I do. But throughout my career, I've spent quite a bit of time shouting and complaining at architects to sort of say, stop making changes to this design model all the time, because I need to get some visualizations out. I've got a deadline here. But I've been dipping in and out of gaming engines, picking up some good skills in programming, general things CGI and 3D engine based. So I work for a company called Wilmot Dixon. It's a UK-based company, one of the leading Tier 1 construction contractors in the country. So that means that we are right up there with the very best in the entire country. It was established in 1852, where it all started with one man, John Wilmot, where he built a well for just £1. But thinking about the current state of the UK economy, that's probably about $1 now. But since then, it's been going on about 170 years as a family-owned business, currently in its 5th generation, with our CEO now, Mr. Rick Wilmot. But born out of Wilmot Dixon is Collida, and that's the specific part of the business where I come from. Collida connects a customer to pre-designed, yet high-performing buildings, made out of essentially a kit of parts that we can bring together to create those buildings. We have products in the residential and the educational markets, and we're looking to expand. Collida is a customer's way of achieving net zero carbon in operation, to less risk, and to a better future. So, quite simply, it is a better way. So I'm just going to flash up a few images on the screen here, and I'd invite you guys to just have a look and ask yourselves, do you actually understand these images? And if you do, that's great. Maybe then just ask yourself, how are you actually interpreting them? And do you think that other people will interpret them the same way as you? Design drawings, floor plans, elevations, sections, details, and more. Pretty much a barrage of construction drawings. Pretty much the point of view of most customers in the construction industry, many of which will have never seen this type of drawing before. So how can we expect them to actually understand our designs? This has been going on for a long time. There's a distinct lack of communication from party to party in the entire construction process. And the one that's the most confused is often the customer. But at Collida, because we use standardized building blocks, that means that we know exactly how much they cost. We know how to make them, how long it takes to make them, what they look like, and how they affect our environment. So, how can we communicate all of this in a way that the customer can understand? Quite simply, we just use visualization to show them. And we drew up a concept, or a mock-up, of a visualization platform with the goal of being near photorealistic, with a goal of something that a customer could interact with and change in real time, and then understand the consequences of those changes be it time, cost, visual appearance, or sustainability factors. A platform that would leverage Collida's standardized building blocks, link to our supply chain, and simplify our procurement process. And I wanted to tell you a bit more about my journey to help all of this become a reality. And it starts with identifying the best real-time engine to deliver this. And you can pretty much guess where this goes. And it was important to find one that would bridge a gap between an architectural design model that's always changing and always evolving, and this interactive environment that we are building too. Something that could connect to external databases to push and pull information and update seamlessly. Something that would stop me remodeling things all the time. And when it came to looking at the Unreal Engine, a nice partnership was formed. And there was an interesting tool that had been recently developed inside it called Visual Dataprep. So for those that are new to Dataprep, first, it requires a datasmith import. And this can originate from a variety of modeling packages. There are plugins for Revit, SketchUp, 3D Studio Max, Rhino, and more. And we can download all of those from the Epic Games website. Once we have that datasmith file, we import it into the Dataprep environment. And this acts as essentially a temporary space that we can automate predefined processes on, or recipes, before it is then committed to the current Unreal Engine level. The whole thing acts as a reusable pipeline, where we first will find an object that we want to affect, called filtering, and then we act on that object in some way, which is called an operation. So it's just filters and then operations. And we're preparing our data, hence the name, Dataprep. But taking that one step further, it's possible to create an instance of a Dataprep pipeline asset. This instance will take a different datasmith file. And the key difference on the instance level will be exposed variables that we could change depending on that instance. So we could, for example, have a house design. And on the instance level, we expose what materials we are substituting, ending up with different color options. So a quick overview of the Dataprep user interface. On the top right-hand side, we have the area that we specify which datasmith file to use. In the middle, a 3D viewport, which will give us a preview of that datasmith file, both before and after the Dataprep pipeline has been executed. On the bottom left-hand side, we have all of our available filters and operations, which we can drag into the main Dataprep pipeline window, which acts from left to right, and we can start to build up some logic. Now, Dataprep comes shipped with some great out-of-the-box filters and operations, but it is possible to create our own using Blueprint, and I'll explore a few that I've created today. But coming back to our journey in our platform, we started getting our hands dirty with Dataprep, started to learn a bit more about it, and we experimented with some of the built-in functions like set mesh, add tags, and substitute materials. And I wanted to touch a bit on the set mesh one. It's a great little function. It does exactly what it says on the tin. We can replace one static mesh with another. So for example, we could have a chair. It's a happy little chair. This has come from our design model. And up to this point, this chair has done exactly what it's needed to do. For our architects, it's enabled them to get out drawings, plans, sections, elevations, and so on. But for our purposes, for visualization, it doesn't really look very comfortable. So using the set mesh operation, we could replace that chair with a higher quality asset. And that's great. We used it quite extensively. But it wasn't long until we actually found a bit of a sticking point. In most cases, when you do author a nice high-quality asset in your modeling software, you'll like to model around the origin point. But then models coming from design models where we don't have control over where that origin point is means that sometimes when we do replace a static mesh, it would feel like our object would essentially just disappear. But in reality, it's probably somewhere way off in the level that we're going to go and track that down. And we could. So just for illustrative purposes, we could track that chair down, drag it back to exactly where it needs to be, under a classroom table, for example. But it's not really a scalable solution, is it? Imagine doing this for every single chair in a classroom, and then for every single classroom that we design. It's about 30 chairs in our classrooms, and I'm not really going to do the maths, but you can imagine how many classrooms we've got in that building. That's a lot of dragging and a lot of chairs. But taking a step back and having a think about it, both of those chairs are of similar physical size, similar dimensional size. So how could we use that to our advantage? And this is where we started to look at Blueprint and maybe create a custom operation to see how we could solve this. Going back to the Dataprep UI, and built into it, on the left-hand side, is a little green button with a drop-down. And this is where we can create a custom operation. After doing so, we're greeted with a blueprint graph, where we add variables on the left-hand side. These are exposed to the user interface widget this operation will represent. We have access to an array of objects, and these objects will represent what the current filter outcome has found. From there, we can loop through that array and start to build up some logic. So coming back to our chair. In Blueprint, we have access to an actor's bounds. And these will give us some values based on the size of an object. We can identify the center point and the extents. And using these, coupled with the original location of an origin point, we can do some maths to essentially overlay the new chair on top of the old one, like a center-to-center snap. And this is great. And this might get us there, say, 90 to 95% of the time. But what if those two chairs might not be exactly the same physical size? What if, after doing that, the wheels are slightly embedded in the floor or the wheels are slightly floating? We can start to build extra functionality into our Dataprep operations. Maybe after that happened, we wanted to rotate the object 180 degrees. We can build that into our function. With regards to the wheels, maybe we wanted to move the object up a little bit. We can build that into our function. And these functions can grow to any size that we like, completely bespoke to our needs. And this is where it really became apparent to us that the full power of Blueprint and the Unreal Engine is available through Dataprep. So coming back to our platform. Up to this point, we made some good progress. We'd swapped out some finishes, high-quality materials, swapped out some meshes, center-to-center snap. We'd built a simple UI and some basic navigation controls. The next challenge was to get some configurable functionality, actually getting the user to engage with the system. And we started off by wanting to change finishes and materials. We wanted to have a simple user interface based on categories that the user can scroll through and change their finishes. And we filtered out these categories using metadata values in Dataprep and assigned unique identifiers based on that metadata. Therefore, the interface would know what objects to affect. This is starting to give the user some power over their own decisions, rather than traditionally being given a simple set of color swatches to choose from. with little understanding on how those choices will actually affect their space or their building. But as well as finishes, we also give our customers the chance to change the geometry of the product, so such as the size or the layout. For our houses, do we want pitched roofs or flat roofs? In our education platform, do we want rows of desks and chairs or groups of desks and chairs? This is the type of change that in our architectural design models in Revit, our architects modeled these using separate model groups and started to move towards a real digital kit of parts that they could swap out when they needed. And that was my challenge, to bring this into the Unreal Engine platform. And the first one that we decided to look at was the downstairs layout of our houses. By default, the house is all open plan downstairs, with the kitchen at the rear, as we see here, and the living space at the front. We have the opposite, with the living space at the rear and the kitchen at the front. And finally, not shown, but what we like to call a cellular option, where both spaces are separate rooms with walls and doors between them. So we wanted to get these layouts into the engine and start changing between them. And we did get that working, but not really in the way that we wanted. Dataprep's default behavior is to place its output into the level as a level stream, which is essentially can be thought as a sub-level of the current level. And that level stream will contain all of the actors that's inside that datasmith file, which is fine for most cases. But in our case, each level stream was representing a different configuration of one of our products. So looking towards the future and for long-term scalability, it would be difficult to manage an ever-growing library of level streams this way, each coming into the same Unreal Engine level, taking up resources and memory. As our platform grows, we might end up with hundreds and hundreds of different options, all coming in to the same environment. And this was an interesting challenge to solve. We needed some way to essentially turn that level stream or that model group into a library group. But then, thinking about it a little bit more, this could actually be captured just as data, just as text, as all we really needed to know was the object's geometry, or its static mesh path, and its transformation. So what did it look like, and where was it? If we could capture this data, we could then read that back into the engine at runtime and recreate those objects in a far more flexible format, such as a blueprint class, something that could be spawned, changed, manipulated, deleted, and then respawned simply. And there are many forms that text-based data can be read into the engine, such as CSV. But the one that we decided to go for was JSON. No, not him. This one. So JSON is a very flexible file format. It can be used to store different types of data, such as strings, floats, booleans, and arrays of that data. It can also store an object type, and we'll get into that a little bit later. So since all of these objects were inside our Dataprep environment, we had access to their properties. The question then became, could we use a Dataprep operation in Blueprint to create a JSON file for us? And that's exactly what we did. We got to work on a function that would first create an object representing the entire model group with properties such as the model group name, the model group's unique ID, and so on. And within that, an array of objects. Each of those objects would represent an individual piece of geometry. So an object for a wall, an object for a table, an object for a chair, and so on. Once this Dataprep pipeline would execute, we would end up with a text-based representation of our entire level stream that we could then read into the engine at runtime and recreate it as a hierarchy of blueprint classes. The system would know what JSON files to read based on the user's configuration choices. And this brings us to the current iteration of our platform. We have a pipeline with Dataprep that is robust, flexible, and secure that we can update seamlessly. We're taking steps towards a real digital kit of parts that our users and customers can engage with and understand clearly. Our library and our designs are always expanding, and our Dataprep pipeline can deal with all the changes that need to happen there. As we're looking at here, our education platform has over 50 model groups, all coming in through Dataprep, converted to JSON, and then being readied to the engine. But a byproduct of having a complete pipeline with the goal of near photorealism means that traditional visualizations, such as stills, images, animations, are only just a few clicks away. In Unreal, we have tools such as the movie render queue, high-resolution screenshot, and more. And we can turn on path tracing. But what separates a great visualization to just a simple model with some pretty features turned on would be other factors, such as storytelling, high-quality assets and materials, randomizing transformations of objects, and imperfections. But how can we do this in a live design environment without hard stopping that design and remodeling parts from scratch? How can we place objects into the scene without hand placing them ourselves? How can we automate some irregularity? Well, we can just write some Dataprep operations. In our education platform, we had the idea of telling stories about how the space was used by adding simple props and simple clutter objects to the scene. A table could have some pens, pencils, notebooks on it, for example. All of this would contribute to the overall visual fidelity, making the user feel a little bit more comfortable using the interactive platform. Once again, helping to reinforce our goal of strong communication. But first, we needed to deem what objects would have clutter on them. And we could just filter these out in Dataprep. And from there, we can use that act as bounds to identify the top surface of that object, the size of that surface, and randomize placement of objects within that surface, collision checking to make sure that none would overlap. Since these objects were then created in Dataprep, they were captured in our JSON data and saved to that model group. We could build in some Dataprep instancing and have different arrays of objects depending on which classroom type it is. So a general classroom could have stationery like pens, pencils, notebooks, and something like a science laboratory could have more equipment-based stuff like Bunsen burners and flasks. All of these placed using the same functions without the need of having to go in and manually do any of that work ourselves. But, of course, there will be cases where we do need to be quite specific and quite manual about certain placement of objects. So let's write a Dataprep operation to do that. This operation could take just an array of static meshes And against that, the transformation of where that static mesh needs to go in the level. Once again, as the Dataprep pipeline executes, these objects are created into the scene, then saved into our JSON data. So if we do require the complexity of manually placing objects, we have the power to do that too. Another way that we can start to break away from the picture-perfect sharp CGI is to randomize the transformation of some objects. In reality, loose furniture, like tables and chairs, are placed by hand, not by a computer, at perfect 90-degree angles. A Dataprep operation to do this for us could take a single float that would represent either the maximum amount of rotation or the maximum amount of movement an object could do based on any axes. We could randomize that value, and after applying it, each object will vary slightly, layering on that extra element of realism that most people will overlook. Once again, all done without the need to go in and manually change positions of objects. But out of the digital and into the physical, I mentioned at the start that Collida's designs have a central mission of sustainability. Our houses are built to Passive House standard, and our schools are built to net zero carbon in operation. But to test just how thorough our design thinking was, we decided to build a pair of prototype houses to challenge our design in reality. Since then, it's become a show home, a place that we can invite our clients and customers to come down and get a sense of a look and the feel of the space. We're building homes, not houses. And since our Dataprep pipeline was already utilizing Collida's standardized building blocks, we were able to essentially recreate this model in our interactive environment. We tailored finishes and props to the real thing, ended up with a model that was strikingly close to the real thing. When our customers do come down, they're able to be both inside the physical space and the digital space at the same time, where they can carry out as many what-if scenarios as they need in order to justify their own design decisions. And if they're not physically at the space, they can view the platform on any device with a web browser using pixel streaming. And then, if we do decide to turn on some far more glossier features like path tracing, it doesn't take too long at all to generate an even more photorealistic image. And side by side with some official photography of the house, there's not much in it. In fact, some members of our own design team actually had trouble differentiating which one was real and which one was CGI. I'm sure all the graphical experts in this room could tell. And this really brings us full circle. Our customers are now seeing exactly what they're getting. They don't need to rely on construction drawings that they don't understand. And I mentioned at the start that essentially I like to say that my job is to color things in. Using Dataprep, using Unreal, and using this visual platform, our customers get the chance to do the coloring in for themselves. Thank you very much, guys.